now want to go through the process of helping you understand vNets and subnets. Now, the first thing I want to say in regards to Azure and virtual networks is that if you have an understanding of just how physical networking works, even in like a traditional on-premise environment where you have to have what are called subnets, and you're running a TCP/IP based network. Granted, it's still to this day, even though we do have TCP/IP version 6 out there, the majority of everything that's running is still TCP/IP version 4, which is what Azure is running and kind of what we're focused on here. Your virtual networking concept is very, very much like on-premise networking. So the same kind of concepts that you have learned and used in the on-premise side of things in regards to TCP/IP is pretty much what you're going to find is running in Azure. All right. Now, when you start using resources, there are all sorts of types of resources out there that communicate and work on a virtual network, or VNet as it's called. All right. Of course, virtual machines are going to have vNICs, and those vNICs are going to interact. Virtual Network Interface cards is what that stands for. They're going to interact on the virtual networks. All right. Now, the virtual network is within Azure, within their Azure networking space, and it's able to route traffic across that virtual network and communicate with the internet if you attach public IP addresses and all of that. And the virtual networks even have a DHCP service, a Dynamic Host Configuration Protocol service, that will issue out the addresses that you set up in the address space that you have. So what I want to do now, I want to draw some of this out and help you visualize it before jumping in and using it. Okay, so we'll start by setting up a VNet in this graphic. Now, the VNet is going to represent a network as a whole, all right? And we'll say that this rectangle is going to represent the VNet as a whole. A VNet is going to be made up of an address space, all right? An entire range of addresses that make up the whole virtual network, all right? So I might call this VNet, we'll call it VNet A. All right, let me lower the font down just a little bit here because it's taking up a little bit too much room, but we'll call this VNet A, all right? So let's see, there we go. And basically VNet A, the address space will be, let's say, from, we'll say 10.1.00/16. Now, I'm not here to teach you TCP/IP. You kind of have to have a little bit of an understanding of TCP/IP coming into this, but that if you do the math on that in TCP/IP, there's basically 65,000 addresses that would be available within this address space. Okay, this is a very common type of address space in a private network that you use. The /16 means that this would have a subnet mask of 255.255.0.0. Okay, and that would make up basically 65,000. There'd be a total of 65,536 addresses. You have to really subtract a couple there, but roughly 65,000 addresses. However, we're not going to need 65,000 addresses on all of our given subnets, because ultimately, here's the thing: you have your virtual network, which is this square as a whole, but then you have to set up what are called subnets. Just like in traditional TCP/IP networks, you have the network as a whole that might represent the whole network, and then you might have subnets that go inside that network. Okay, so from there, I might have, let's say this right here will represent, this is going to represent a subnet, and we'll call this subnet A. All right. And so from there, it might be 10.1.1.0/24. Okay, so you're slicing off a piece of that 65,000 chunk of addresses by doing that. You're basically saying that you're going to roughly have 256 addresses. Actually, in TCP/IP, you probably know this. If you know TCP/IP, you have to subtract 2. You can't use the very first address on an addressing system, and you can't use the very last address. The very first address represents what is called the network address in TCP/IP, and the very last address is what we call the broadcast address. So in reality, you would have a range of addresses that would be available: 10.1.1.1 to 10.1.1.254. Now, Azure also does reserve a couple of other addresses for itself, but I'm not going to get into that right now. That would be your actual range that would be available. So the virtual machines and all that go on this virtual network would be able to take those addresses, and you'd have a DHCP service that would handle this for each service, each subnet automatically. All right. So then I might have another subnet over here. Let's create another subnet, and we'll call this subnet B. All right. And then maybe subnet B is going to be 10.1.2.0/24, which means you would have a range of 10.1.2.1 to 10.1.2.254. That would be your range, all right, of addresses that are available on that subnet. Okay. And then, of course, let's say you want to have another subnet. We'll say subnet C over here. Each subnet could contain different virtual machines, and you could be putting them on different subnets for that purpose. One of the reasons for putting things on different subnets and not just doing one big subnet is that you could have security rules and stuff for that specific subnet if you want. But not getting into the IP filtering just yet. So then subnet C might be 10.1.3.0/24. Hopefully you're seeing a pattern here, and you would basically have a 10.1.3.1 to 10.1.3.254, and that would be your range. So again, you can put your different virtual machines on these subnets, and from there they would be able to communicate. One of the interesting things about having subnets in the same VNet is that they can automatically talk to each other. So, for example, if you had a virtual machine here, we'll say this is a VM, and of course, virtual machines have VNICs. A VNIC is going to be the object that represents the adapter card for that virtual machine. That VNIC would automatically get an address from the DHCP service that the VNet uses, okay? And then if I had another virtual machine down here and maybe another virtual machine over here, all of these could talk to each other automatically. They could automatically communicate. They could automatically talk to each other, and traffic could flow between those different subnets. That's automatic. Now there is this thing that is called an NSG. An NSG is called a network security group. NSG. All right, I'm going to put a little square around it. NSGs are IP filtering capabilities, and what they basically do is they can restrict traffic from flowing to one place to the other if we want. NSGs can be placed either directly on a VNIC, or they can be placed on a subnet as a whole. So, for example, if I had some kind of VM here and I really needed to lock down what could talk to it, maybe I want the virtual machine in subnet A to talk to this VM, but not the one in subnet B. I could actually do that by using NSG. I could place the NSG on the whole subnet and restrict this VM from talking to the whole subnet, or I could just place it on this VNIC and restrict this guy from talking to this VNIC. And of course that could include things coming from the internet and all of that stuff as well. All right? Because of course that is the other thing that I'm not looking at just yet, but you can assign public IP addresses to all this too, and you can allow things from the internet to get in. In this case right now, since I don't have any kind of public IP address, there's nothing that's actually talking from the internet to these machines. All right, these machines can actually go out to the internet if you want them to, but things can't flow in from the internet. All right, so kind of summarizing what we're seeing here, we've got a VNet called VNet A, and we've only got one VNet, and we've set the whole entire range, which is 10.1. 10.10.00. Now, if you were to actually think about that whole range, you would have 10.1.0.1 generally up to 10.1.255.254. That would be the full range, the full 65,000 range. And what these subnets are doing is they're breaking these up into smaller chunks, smaller, more manageable chunks. The general rule of thumb, most people kind of go by this. You don't have to go by this, but the general rule of thumb is your subnet should be /24 based. That's 255.255.255.0 on the subnet mask, which gives you roughly 254 addresses, even though Azure does reserve a few more than that. You get roughly 250 when it's all said and done, okay? Depending upon what Azure reserves for itself for routing traffic. All right. But again, all of these subnets by default will be able to communicate with each other because they're part of the same VNet. And the NSG could be used to restrict that. Now, don't think of an NSG as a firewall. It is an IP filtering system, which is something firewalls can do. But Microsoft actually has a thing called the Azure Firewall that handles the more intense stuff in regards to securing things. All right. Now, this is just looking at this from the perspective of a single VNet. All right. Now, in your enterprise, you might have multiple VNets that are associated with different projects and things like that you're working on. So what I want to do now is I want to look at this from the perspective of not just one VNet, but multiple VNets. All right, so looking at this from a larger standpoint here, imagine you've got multiple VNets that you're working with. Maybe you've got different projects going on, and each project is dealing with its own VNet. There's various things you could do here, but so we'll do this. We'll say that this represents our first VNet here. All right, we'll call this, instead of VNet A, we're going to call them VNet. We'll do VNet 1, 2, 3, so on and so forth. Okay, so VNet 1, and we'll say that the range is going to be, put the range up here for this, 10.1.00/16. All right, and then let's do, we'll say VNet 2. And the range will be the 10.2.00/16. All right. And we'll do, make that a little bit smaller because I want to fit one more in there. VNet 3 is going to be 10.3.00/16. And then we'll do one more over here. Try to fit that in, and that will be VNet 4. All right, 10.4.00/16, and we'll just kind of center this stuff a little bit better. Move this over a little, move this out here a little bit. Okay, now this is actually a pretty common scenario too, where you might have what is known as a hub and spoke scenario. A hub and spoke scenario might be where you've got, one main VNet where sort of is the hub where everything comes in, and then different spoke VNets that are interacting with that hub VNet. All right, and so of course now you've also got to consider you've got some subnets that can fit onto this, right? So maybe we've got, let's do this. We'll say this. This is going to be, we'll call this subnet 1A, and maybe the range for that would be 10.1.1.0/24. And then maybe we've got another subnet over here, and we'll say this is subnet 1B, and this will be 10.1.2.0/24. So we're just slicing this up into chunks of 254, roughly 250, when it's all said and done from this full range here. And then of course you can do the same thing on these subnets over here. You could have subnet 2A, and this would be 10.2.1.0. You can use the 10.2.0 subnet as well, but I like to do it that way. I like to use the 1 because it's the first letter of the alphabet if I'm naming this. But so then we could do another here. All right, we'll say subnet 2b, and that would be 10.2.2.0. You see the pattern, I'd imagine, at this point. And then over here, let's just keep it simple. Let's just give each one of these, we'll just give them one subnet. All right, so then we'll say this is going to be subnet 3a, and that'll be 10.3.1.0/24. And then we'll do the same thing over here. We'll just keep it simple and give it one subnet. And it'll be subnet 4a, and then that would be 10.4.1.0/24. Okay. So this is my strategy. Now, the other thing I want to clarify is that you have to consider the fact that you may at some point connect your on-premise network with Azure, and you got to make sure the addressing system that you're using in Azure does not conflict with the addressing system that you're using on-premise. That's very important. It's a huge pain if you've got conflicts. So if you're using this addressing system on your internal network, you don't want to be using that in Azure. You want to use something different. This is why we use the 10, because a lot of companies are using the 192.168 or the 172.16 strategy on their on-premise network. All right. So just think about that. All right. Now, the other thing I want to point out here is that that even though these subnets can talk to each other, and these two subnets can talk to each other. Essentially, none of the subnets can cross vNets at this time. So, unfortunately, the thing you got to understand about all of this is that when you have separate vNets, they don't automatically have routing between them. Okay, like up here. These subnets are all part of the same vNet. They've automatically got what is known as system routing enabled. And so they automatically can route traffic between these different subnets. But down here, we don't have that automatically. Okay, so there is a way to handle that, and it's a thing called peering. All right, peering allows traffic to flow between the different vNets. All right, so I can actually create this thing called a peering. And peering actually happens from both sides here. That's why I'm drawing these two little arrows. If I want, and this is traditional. If you're doing a hub and spoke type scenario, you would do it this way. Instead of connecting them all together, I'm going to make everything travel through the hub. Now, in the hub VNet, what I might do is I might have what's called the Azure Firewall, and the Azure Firewall can basically police traffic flowing between the VNets. All right. Now, keep in mind, you can still have NSGs, which will do IP filtering and all of that, but the NSG is not a full-blown firewall. It just does what's called packet filtering. If you want to police things, maybe you've got here's the internet right here. All right. Let me just kind of get rid of the little thought bubble thing here that it puts on there. But let's say this is the internet, okay, and you're trying to allow traffic to flow, from the internet into your Azure environment, which you very well can do. You can set up a public IP address and all that. You might set up a Azure firewall. All right, we'll say Azure firewall right here. This is what we call a virtual appliance, and it might be hooked into that subnet, and you might have a PIP, a public IP address, coming in here. And what happens is traffic trying to flow to any of these other subnets. Maybe you've got some virtual machines. Let's just copy this just to keep it simple. Maybe you got a virtual machine here, and you got a virtual machine over here. Maybe you got this is a web server or something like that, and you're having to police traffic flowing in. Everything would have to flow through this Azure firewall before it could get to any of these VMs. And same thing, if you wanted to allow these various virtual machines to communicate with each other, you know, maybe you're going to allow this guy to communicate with this guy over here. You can make it where everything's got to go through this firewall. So Azure, once you set your peerings up, and let me just kind of clarify in my diagram that that's what those lines are real quick. All right. So this is a peering, right? This is a peering, and this is a peering. Once you've set that up, you've got two peerings really, because it's a send and receive. You can actually make it where you can send traffic from a VNet to another VNet, but you can't receive traffic. That's something else you can do. But in this case, I'm allowing traffic to flow both ways. But anyway, I can use these things called UDRs, which is called a user-defined route. Okay, a user-defined route, UDR, user-defined route. This will allow me to direct traffic and force traffic to go through something if I want. In other words, I can make it where, you know, any of these guys right here, any of these subnets want to talk to each other, they have to flow through the Azure firewall. I can use this thing called a user-defined route to control that traffic. All right, if I want. So maybe I've got, you know, I've got virtual machines on each one of these subnets here. All right. Ooh, just barely fit, but it did fit. And I can require everything to have to go through that Azure firewall if I want. The other thing I can have is I can have load balancers and everything else. You can have you can do what is known as virtual load balancing, which is really neat. And you could maybe, if you were in a situation where you had a web server here and a web server here and a web server here, and you wanted a load balance between those three, you could do that. All right. And then finally, again, talking about our on-premise network, this triangle is going to represent your on-premise network. Maybe your company has a Microsoft domain, and the symbol of a triangle is always going to represent a domain. All right. So this is what we call ADDS, Active Directory Domain Services, and that is on-premise. All right. We have various ways that we can actually connect an on-premise network into Azure. One of the things we can do is we can do this thing called a VPN gateway. All right, a VPN gateway, VPN GW here. A VPN gateway is another type of appliance that we can have, all right, and it can establish a connection with an on-premise domain. So traffic can flow securely into this VPN gateway. And really what's happening, just to give you a better look at it, is it's really, you would have to have a what's called a VPN concentrator. And that VPN concentrator would be on-premise. Let's make it orange. It would be on-premise, right? And this VPN concentrator could establish a internet connection, and then from that internet connection, you could connect it into this VPN gateway. And from there, traffic can flow from on-premise directly into your subnets if you want. There's another solution that will connect everything together called Express Route. So again, this is called Express Route. Some people will call it a direct route or a direct connection into Azure. But what you basically do is you work with a telecommunication provider, and they install hardware at your office. They install hardware at your office, and what that basically does is it uses the telecommunication private network and connect directly into Azure that way. So you can use a VPN concentrator to do what's called a VPN gateway and connect into Azure. It uses the internet, so it's virtually private, or you can use a direct connection from your on-premise environment into the cloud as well. So those, and of course that's going to be the more expensive route to go, but you have a private connection through the telecommunications provider with Azure, and you can have insanely from speeds of 10 gigabits per second up to 100 gigabits per second in certain regions, if you spend the money. Of course, again, you're talking some serious money when you start getting into that. All right. So hopefully these drawings, I know this is a bit of a mess, but hopefully this drawing gives you a better, at least a visualization now of kind of how all this sort of works together. I know I haven't really explained doing any of this yet through Azure, but now at least you can kind of visualize it before jumping in and doing it. Hey, this is John Christopher. I hope you enjoyed that video, and I want you to know that I'm trying really hard to grow this channel, so I hope you'll give me a like and a subscribe. Also, if you'll check the description in this video, I've got a link for you that can show you how you can get access to all my different courses. I have lots of different Microsoft certification courses that'll help you pass your exam. All right, thanks a lot for watching the video, and I hope to see you again.